Good afternoon, students. Today we are going to discuss about occurrence of metals. Elements or compounds which occur naturally in earth crust are known as minerals. You know that minerals from which pure metals can be extracted are known as mineral ore. In this flowchart, we can able to see that steps involved in the extraction of the metals from ores. It is based on the reactivity series. You can see this reactivity series in page number 45 in your book. It has been given that more reactivity is metals such as potassium, sodium, calcium, magnesium, aluminum, and the medium reactivity zinc, iron, lead. And also you can be able to see the least reactivity such as copper, mercury, silver, and gold. On this basis only extractions based on. This is a flow chart. You can be able to see the different extraction methods based on the reactivity. Next we are going to see about the reactivity series. I told previous class we have discussed about this reactivity series. Mainly you can see that sodium, potassium, calcium, magnesium, aluminum have most reactivity metals, and you can see that copper, silver, gold, platinum these are least reactivity. On this basis extraction is depend upon. Next we are going to see extractions of pure metals from its ore. What are the steps of extractions of metals from its ore? First step is enrichment of the ore, and second step includes extraction of metals, and third step involves refining of metal. Normally you know that major source of metals are from the earth crust, so it contains some impurities, salt and soil, sand, soil, etc. This is called as gangue. Gangue is nothing but ores contain different impurities in it, such as sand, soil, etc. These impurities are known as gangue. Next we are going to discuss about extracting metals which are low in the activity series. As we have discussed the reactivity series, the low reactivity or least reactivity metals such as copper, mercury, silver, gold, these are least reactivity. Okay, we have discussed in the reactivity series. On this basis, metals which are low in the activity series are unreactive. These metals are mainly in oxide form. Oxides of such metals can be reduced to metal by heating alone. For example, you are taking a cinnabar. Cinnabar is nothing but mercuric sulfide. It's a ore of mercury, cinnabar. Here, a mercury sulfate you are treated with oxygen, 3 molecules of oxygen. It has been heated, produces mercuric oxide plus 2 molecules of sulfur dioxide. Further, this mercuric oxide heating produces pure liquid mercury. The metal which is in liquid stage you can already discuss as mercury. It's a liquid. A metal which is liquid is mercury. Okay. By this method, a low reactivity metal such as mercury has been purified and been extracted. Next we are going to discuss about extracting metal in the middle of the activity series. What are the metal in the middle of the reactivity series such as zinc, iron, lead? These all the metals comes in the middle of the activity series. These metals are moderately reactive. These metals mainly exist in sulfides and carbonates in nature. Before reduction, these metal sulfides or metal carbonates must be converted into metal oxides. Okay. The sulfide ores are converted into oxide by heating strongly in presence of air is known as roasting. A process by which roasting is sulfide ore is converted into oxide by excess of air is known as roasting. Next, the carbonate ores. Carbonate ore are converted into oxides by heating in limited air supply. This is known as calcination. Two processes taking place in the middle of the activity series metals, for roasting and calcination. Let us discuss the example zinc sulfate. For example, zinc sulfate, a sulfate ore is converted into zinc oxide in excess of air. It forms zinc oxide and 2 molecules of sulfur dioxide. Similarly, a carbonate ore, a zinc carbonate, with limited amount supply of air are heated forms zinc oxide and carbon dioxide. The reduction of metal oxide can be reduced to metal using reducing agents such as carbon. Okay, this is extracting of middle of the reactivity series. Next we are going to discuss about extracting metals towards the top of the activity series. What is the top of the activity series? You can know that metals such as potassium, sodium, calcium, magnesium, aluminum, these are the top of the activity series. The metals are highly reactive. You know that these metals are highly reactive. They cannot be obtained by heating. For example, sodium, magnesium, calcium are obtained by electrolysis of their molten salt, molten chlorides. Nothing but this is electrolysis process. These metals can be extracted at cathode, anode, sodium, at anode, chloride. This is, we can explain the electrolytic refining process. Refining of metals. Refining of impure metals is done by using electrolytic refining. Here you are taking a impure copper used as cathode, acidified copper sulfate used as an electrolyte. When electric current is passed through this impure metal, from which anode gets deposited in electrolyte solution, whereas pure metal from the electrolyte deposited the cathode. Deposition of insoluble residue form dissolution of anode during the commercial electrolyte. That means this is a electrolytic refining method. The solution inside is copper sulfate, is an electrolytic solution, and the pure copper will be deposited at the cathode. Okay, and the impure present in the copper will be present at the anode of electrode. Below you can see that some black color. This is nothing but impurities of copper metal. Impurities present. This method is an electrolytic refining method. Next method we are going to see is corrosion. What do you mean by corrosion? Previously we have discussed about corrosion. Metals normally when exposed to a moist air form a long period of time. They become corroded. This is known as corrosion. We have already discussed metal, for example iron, when exposed to air forms iron oxide. We have discussed. Similarly, silver reacts with the moist air and becomes black in color due to silver sulfate coating. We have discussed in previous classes. How we can prevent this kind of corrosions? Rusting of iron can be prevented by oiling, galvanizing, painting and greasing. By this method we can prevent corrosions. And to protect the steel and iron from rusting, the thin layer of zinc are coated on them. This is known as galvanization. Galvanization method is preventing rusting of iron. A coating of zinc has been coated around the iron metal. This method is called galvanization. By this method we can prevent the corrosions. Next we are going to see about alloys. Alloys is nothing, a mixture of two or more metals and non-metals is known as alloy. For example, brass is an alloy of copper and zinc. Bronze is an alloy of copper and tin, and solder is an alloy of lead and tin. Amalgam is one of the metal is mercury. These are alloys. Alloys means a mixture of two more metals or metals, and non-metals is known as alloys. From this we can conclude that this chapter we are discuss about metals and non-metals and all the properties, and we have discussed about the ionic compounds previously, and today we have discussed about the extractions of different metals based on the reactivity. How far based on the reactivity we are extracting different methods of low reactivity, moderate reactivity and high reactivity metals, and we will discuss about corrosions and how corrosions, prevention of corrosions we have discussed, and we discuss about the electrolytic refining method. How electrolytic refining method, this is based on electrolyzers by passing electric current we have discussed, and lastly we discuss about the alloys. What is alloy? Means mixture of two or more metals, and non-metals are known as alloys. Thank you students.